Okay, now this is actually the fun part. We're going to implement the terminal user interface. Right, so this is going to be a console application, right? So this class is only going to have one function. It's going to be called run, and it will run in a loop. That's it. And all the other dapps that we're going to have here are going to be private, right? So there's just going to be only one function called run. So we're going to have a variable called car. We're going to have a variable called should keep looping. Right? So as long as this variable is true, we're going to keep looping and ask our users for input. So we're going to say while should keep looping, do some code over here. We're not going to have the code yet, right? Okay. And at the bottom, at some point, we're going to have a function called exit, which is defined inside of run. Okay. And exit will, it will print out some stuff, and it will also set this variable to false, right? So at some point, it will say should keep looping to false, right? So at some point over here, we're going to use, we're going to read the user input, and at some point he's going to say, okay, I'm done now, and then we're going to call the function called exit. In fact, let's implement the exit function right now, because all it needs to do is it needs to print out some stuff, right? So I'm going to print line. We're going to have an empty line in the beginning and in the end, and in between we're just going to say until next time, like this. And then all it will do is it will set the should keep looping variable to false. Okay. So how do we ask the user for input? So there are many ways to do this. I chose something that resembles monadic design, and if you never heard something like this, don't worry, we're going to have videos about that. So we're going to have a function call to a function called wizPrompt, and we're going to implement wizPrompt ourselves, right? So we're going to have it over here. Actually, it's going to be called wizPrompt, and the idea is that we're just gonna pass it a function. So wizPrompt is a high order function. So we're going to pass it a function that will be executed once the user puts something in, right? So we're going to call it on user input. So this is going to be what what the user put in, and this is what we're going to do with it, right? So everything over here is going to be a side effect function, right? And wizPrompt is not going to do anything, right? It's not going to do anything. In the end, it's just going to return a unit, right? Because over here, the return type of the scope is a unit anyway, right? So whatever this function returns is going to be thrown out anyway, right? So wizPrompt, what it will do is it will get the user input, and we haven't finished writing the stuff here. Okay, so it's gonna take the user input by using the standard in class that we need to import. We're gonna import over here. We're gonna import scala.io over here. So we have standard in read line, and we're gonna pass it the menu, and the menu is going to be defined over here. It's just going to be a private def. We can't have a private def inside of a def because remember we're inside of run. Okay, so this is going to be a menu, which is a string, and for now it's going to just say menu. Okay, so then whatever the user typed in comes back, and we're going to convert it to lowercase, and we're going to trim it again, the return of the trimming, right? So now we have the user input, and now we're just going to call the function on user input that is being passed over here. Right, so the user puts something in, and then we're going to call this function. Now, what is this function? And this is the function that we're going to pass in over here, right? So this is going to be this function on user input equals some function, right? What we're going to use is the curly braces to pass this one argument, because remember, if the function gets only the function wizPrompt, if it contains a parameter list with only one parameter inside, we can call it with curly braces. Right? So what we're going to pass in over here is not just a regular function, but we're going to pass in a partial function, right? Because over here we can directly pattern match on what the user put in. You might want to rewatch the videos about partial match. You might want to rewatch the videos about pattern matching if you don't know what I'm talking about. Pattern matching and partial functions. So over here we're going to say case some command, and in our case it's going to be a command E, or if it's a command Q, or if it's exit, or if it's quit. So any of those are just going to call exit, right? And if it's something else, if it's anything else, like over here, right, then we're just not going to do anything. In fact, let me put this arrow over here. We're not going to do anything, right? So it's going to keep looping until we press enter. In fact, if this compiles, not found value menu. What? Oh, menu. Menu, like this, menu. There we go. All right, so this compiles. So let's now, you know, before we finish the entire terminal, let's actually assemble the entire application. Let's go to our last layer, and we're gonna go over here. We're gonna create a file called todo app.scala, right? So this is over here. As always, it's in packages, right? And we're gonna have an object todo app, which extends app. App is just a trait that provides the main method, right? So basically everything that we're gonna write over here is going to be executed when we run the application, right? So let's actually try this. Let's do print line hello world. All right, so now if I run it, we should see no main method. All right, there's no main method in the project to do. First we need to switch into the main project, right? So we can do cd main and only then run. Okay, and we can actually stay in the main project and keep compiling it here because of the way that the dependencies are set up. It's going to compile everything else as well. Okay, so over here what we're going to do is we're going to create a persistence gateway equals in memory persistence gateway. So because it's an object, it's actually not being created over here. I'm just writing it out for documentation purposes, so to say. And over here we're going to create the application boundary. Remember, this is the trait that is defined over here, application boundary, this one. And it's going to be application core, right? Because remember, application core extends the application boundary. So application core, it extends the application boundary and it gets an instance of the persistence gateway, right? So because the in-memory persistence gateway, which is over here, because it extends persistence gateway, we can use it over here, right? Like this. Let's see if that compiles. It compiles. All right, so now we're gonna have a pattern. Remember, we need a pattern to know how to display the time, how to display the deadline. It's gonna use the date time formatter. It's going to be over here, import java time.format date time formatter, like this, and the format is going to look like this, date time formatter dot of pattern. So this is how you create patterns. You don't say new date time formatter, you just do it like this. So this is going to spell out the day for us. This is going to use the long version of the month. This is going to be the day without the zero. This is going to be the year. And this is going to be the hours in 24-hour format, and with zeros, I believe. Do we need zeros? No, we don't need zeros. Let's do this. And this is going to be the minutes, also without the zeros. So it's just gonna be like this. H and M. Yeah, that should be fine. Let's see if it compiles. Yep. All right. So and now finally we're gonna create the user interface. There's no need to abstract over the interface, so the type is going to be exactly the same. New user interface, and it needs the application boundary, and it needs the pattern, like this. Oh yeah, I called it terminal user interface. All right, terminal user interface. All right. Okay, so now all that's left to do is to say user interface dot run. And that's it. So now if we run our application, we should see the menu. And if we type something in, doesn't matter what we type in, if we press enter, it's just always going to display the menu until we press E or Q or exit. So if I type in E, enter, it says until next time. So this interrupts our whole loop. Let's go back to our code, terminal user interface, over here, right? So every time it's something else, it's just going to keep looping. Right, but as soon as we type in E, Q, exit, or quit, then it's going to jump out of the loop. Okay, first let's implement the menu. So over here, this is going to be a string. It's going to be a very long string interpolated string. So we're going to start. In fact, let me actually close this, and on the end we're going to say strip margin. Right. So whatever we do over here with these pipes, remember, I believe we discussed this in the video about literals. I believe, yeah, how the syntax works. Basically, it's going to remove all the spaces like this from here. So it's going to find the pipe, and it's going to make sure that everything is in line, right? So the last thing that we're going to do is we're going to say, please enter a command space. But before that, we're actually going to display all the commands. And we're going to start with a bunch of hyphens. You know how I love hyphens. Hyphens like this. And we're going to implement the hyphens over here. Come on. Def hyphens, which is just a string. And for now, I'm just going to do a few hyphens like this, right? I'm going to have another empty line over here, and now it's going to become, you know, the actual menu. So the first, basically the last one is going to be, not the last one, but sort of like almost the last one. So if it's an E or Q or exit or quit, then we're going to exit the application. Exit the application, right? And over here, if it's anything else, we're going to show the main menu, right? So we're going to keep showing the main menu, right? So as of right now already, we can run it. And it's going to look a bit better, right? So it says, okay, so if you type EQ, exit, quit, it's going to exit the application. Anything else is going to just show the menu. So if it's anything else, it's just going to keep showing the menu, right? Whatever we type in, it's just going to keep showing the menu. And only if you type in E or Q, for example, it's going to say until next time. All right, so let's keep compiling like this. Okay, so what I want to do here is I want to finish the entire menu before we continue. Okay, so I'm gonna do C. We're gonna be able to create new to do. We're gonna have D. I'm just gonna keep it short. Delete to do. Over here we're gonna have DA. Delete all to dos. Over here, we're gonna have SA, which is gonna be like, you know, search for all to-dos. It's gonna show all to-dos. All right, so we're gonna have SD, which is going to be search by partial description. And we're gonna have SID, it's gonna search by ID. We're gonna have UD, which is gonna update the description. And we're gonna have UDL, right, which is gonna update the deadline. Update the line like this. Okay, and okay, let's see. I want a space over here and over here, over here, over here. All right, so now I can bring them all the way over here, right? So this is going to be our main menu. So let's run it and see how it looks like. Run. So this is going to be the main menu, right? So keep pressing enter. It's just going to keep showing it, right? Whatever we type in. Okay, right. So let's go back to compiling. Okay, so let me fix the hyphens because you know, as you can see, you couldn't even see that I'm pressing enter sometimes if I was not typing anything. And actually, let me show you again. Oops. Let me show you again. So if I run, if I don't press anything, at some point, I'm pressing enter right now, and you don't even see that something is changing. I want to be able to see this always. It's just a better user experience. So what I'm going to do is I'm going to display the hyphens in different color every time, right? So the hyphens is just going to be random color plus, we're just going to have, I don't know, 100 hyphens. 100 hyphens, right? Plus console.reset. So over here we don't have to say scala.console.reset because we're not in the SPT build file anymore. We're in the regular Scala file. Okay, so the random color is going to be over here. Random color string equals random index. It's going to be a random next int colors dot size. I'm not sure if I should import or not. Let's not import it. Let's do scala.util like this, right? So this is going to be generate a random index, and we're going to pass this index to colors, right? Random index, and colors is not going to be a function. It's going to be a lazy val. It's lazy val because it's underneath, right? It doesn't have to be a lazy val. It's going to be a vector, which is another collection. So the cool thing about the vector, or about you know, most sequences basically, is that they have an apply function, which is the one that we're calling over here. And if you pass in the index, it's going to retrieve the element. It's a zero-based index. So over here we're gonna generate the index from 0 to the basically last element. These are all the colors that we have. We have the console.black, I'm going to sort them alphabetically. I have blue, and we have cyan, we have magenta, red, white, and we have the yellow, right? So this is all the colors that we have, but I actually don't want to use the black, and I also don't want to use the white like this. Okay, let's see if it compiles. Okay, it does compile. So now if you run it, our menu always had these hyphens, and they're always in a different color. So see now, even if I hold enter, you see this funny rainbow. Enter, 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 enter. Sometimes it's like exactly the same color that is coming after this, but at least now we know that enter was pressed always. Okay, let's back to compiling like this. So the next thing that we want to do is we want to stab out the actual implementation, right? So we're going to have all of these things over here. We're going to have them over there. So let's see, can I do this? Yes, I can. Okay, so I have this, and can I just paste it over here? Sort of worked. All right, so let's do some Sublime magic like that. Okay, so if I hold shift and with my right click, I do this. I can press Ctrl D. I can surround them with quotes, and I can go here. Can do this equals, like over here we're gonna have arrows, and over here we're just gonna have separate functions, right? So here we're gonna call create. Here we're gonna call delete. Here we're gonna call delete all, delete all. Here we're gonna call show all. Here we're gonna search by partial description. Here we're gonna have search or show by ID. Here we're gonna have update description like this, and we're gonna have an update deadline like this. Okay, so now I'm gonna do the similar trick like this. I'm gonna mark them all, gonna go down. So all of this was happening inside of the run method, right? Right now we're actually gonna have a bunch of private defs. So we're gonna insert this here. I'm gonna have private def, all of these, right? They all return unit, and they all, as of right now, they should say, okay, let's do print line to do. Okay, and let's also go down, press enter like this. Okay, so at least this should compile. So they're not, they're not implemented yet, but it should work. Okay, so we're done with the run. We're never going to touch run again. So this is, run just keeps looping and displaying the menu. Okay, so in fact, let's actually run the application now. In fact, let me collapse run so that we just have a bit more space. So now if we run it, if we say C, it will say to do, right? If we say D, it will say to do. Whatever we type in, it's just going to say to do. Okay. All right, let's go back to compiling and let's actually start implementing this stuff. All right, before we actually do that, let me actually show you again how this WizPrompt works. So we're calling WizPrompt and we're passing it a function because we're going to have a bunch of different prompts. Like for example, we're going to ask our user for the ID or for the description and so on, and we're going to use exactly the same pattern. In fact, we're going to start right now. So the first one that we're going to implement is going to be a function called create, and it's going to go like this. It's going to say with description prompt. And in this case, we're not going to use a partial function. We're going to use an actual function. So we're going to ask the user for the description, and it will come back over here, right? And we will be able to use it, right? We're going to implement it in a few seconds, but for now, let me just keep going. So if everything went well with the description prompt, then we're going to call deadline prompt with deadline prompt, right? And over here, the deadline is going to come back. I smell monads. All right, so over here, we're going to have the created to do. It's just going to be to do dot data, right? With the description and with the deadline, which are coming from here and from here. Okay, and now all we need to do is we need to go to the application boundary that is coming from over here, right? And we're going to say create one. Going to pass it the created to do. And over here, we're just going to print line console dot green plus successfully created the new to do, right? console.reset. All right, so this is obviously not going to compile because we don't have these two. So let's implement them. Similarly to the one at the top, it's going to look like this. With description prompt, I'm just going to take a function. We're going to call it onSuccess. Hate it when the cursor is exactly when I'm typing it. Okay, so onSuccess, we're just going to take the description and produce a unit. The whole thing produce a unit. Like most functions in this file are going to produce a unit, right? Because we're side effecting to the terminal everything. Okay, so over here we're going to say user input equals standard in, same as above, read line. So we were passing the menu before, but over here we're just going to pass in a simple string called please enter a description, like this, right? And whatever comes back, we always trim it. Okay, so there's not going to be any validation over here. We could do something like, oh, description can't be empty or some stuff like this. But I believe our application core is already doing that. And even if it doesn't, the whole purpose of this entire example is not to show how to implement the best to do application on this entire planet, is to show you the cake pattern. And I just had to have like a big example so that you see all the benefits and all the trade-offs. Okay, so over here, even though there's no validation, we're still going to call it onSuccess, right, like this, and that's basically it, right? So with description prompt, it gets in this function, right? Hold up. Yeah, basically this whole let me mark it like this, right? So this whole thing comes in over here, right, to onSuccess, and this is what we're calling it. We're calling onSuccess with whatever the user types in. So it comes in here, over here in the description, and is executed, right? And with deadline, it's going to look exactly the same, right? So with deadline prompt, it's going to look exactly the same thing, onSuccess, and this is going to be the local date time unit over here, produces a unit as well. Now this is going to be probably the most complicated function over here, right, in this entire file, right? So we're going to have a pattern with which they can enter the dates, right, our users, right? It's going to look like this: year, month, date without any zeros, hours and minutes. Okay, and we're going to have a format. This is going to be useful for displaying error messages. Hold on, let me do it like this, that it's okay over there. Okay, so we're going to do magenta plus pattern plus reset, and we're also going to have the formatter date time formatter of pattern, right? This is going to be a different pattern, so it's not going to be this one. This is going to be the one that we're going to use to display time. This is going to be the one that we use to input the time. Okay, so now over here we're going to have the user input, same as over here, user input. It's going to be standard in dot read line. This time we're going to use string interpolation. I'm going to say please enter add deadline in the following format space dot trim. So over here we're going to display the format in magenta, right, so that it just stands out a little bit. Okay, so over here we're going to use Scala util try, right? Oh, by the way, we're using Scala util for the second time. So over here, when we're using the random stuff here, we can just say random, because now I'm actually going to import Scala util. Import Scala.util. Come on, like this. Oh, and also we're probably already using the local date. So it's java time dot local date time. Yeah, this one. Okay, so let's collapse run again. Let's go back down to the description. Okay, so over here we're using the try, and over here we're going to say local date time dot parse. Right, so we're going to parse the user input with this formatter that we just created, right? So we're going to expect it to be parsed in this format, and if it's not in this format, then it will then this function is going to throw an exception. This will catch it, and we're going to convert it into option. We don't actually need to, but just for simplicity, because we're not going to display the arrow in any way. We're going to display our own arrow. So see, if we didn't convert it into option, we would have a success deadline over here, right? And we would have failure, and then this would be something that we don't use, right? So this is why I converted into options so that we can have some and we can have a none, and then we don't have these braces over here, right? So it's just some and none. Okay, so on success, well, we're just going to call on success with deadline. Okay, deadline from here. Okay, and on success comes from here. Okay, so, and if it's none, then we're just gonna display an error message. Hit the cursor. All right, so this is going to be a complicated interpolated string. It's going to start with an empty line, right? Then we're going to have a console dot yellow, whoops, dot yellow plus whatever the user put in plus console dot red, right? So this is going to be yellow. The user input is going to be yellow. Everything else that is going to come after this is going to be red. Okay, so usually we do like color and then reset. In this case, we're going to do yellow, red, and only in the end we're going to do reset. So over here, we're going to keep typing does not match the required format. Now we're going to display the format again, format, right? And over here, we're going to do console dot reset. I'm doing it like this because I didn't want to mix string interpolation with with string concatenation, right? Because I could also just add it, right? So I could also just do console dot reset, but I decided that if the whole string is interpolated, then we should probably have as well, even though we have like bad syntax highlighting over here. All right, so I believe it's done. If I didn't make any spelling mistake, oh, of course it did. Okay, so read line. Okay, so L is big. Where is it? L is big, right? Like this. All right. Oh my God. Okay. So value create one is not a member of package application boundary. It's called create one, like this. All right. Oh my God. So many errors. Okay. Not found value created to do. Created. Oh, damn it. Like this. Like that. And okay, this one is closing over here, this one is closing over here, this one is closing over there. All right. I keep spelling it small. Okay, 92 read line over here. Not found value local date time. What's happening? The T is big. What is wrong? Seriously, everything is now wrong. Like this. Reset. Okay. All right. So this actually already works. We can actually try it out. We can run it. We can say create, and now it's going to say please enter a description. Let me show you this to you. So we type in a C. We're calling the function called create. Let me collapse it again. Right, we call create. It's going to do the with description prompt, right? So it's going to run this code. It's going to say please enter a description, and then if we enter the description, even if we enter it with spaces, right? We're going to say description, right? Spaces. Okay. Now it's going to say please enter a deadline in the following format. Now, the description this method was called on success with our spaces description spaces. It ended up over here. And then this method was called, right? With deadline prompt was called with this parameter, right? So now we see this, please enter deadline in the following format. Okay, so let's for now do some wrong format. Let's just type in something in. We should see blah 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 does not match the required format, right? So we see this thing. What's important is that on success is not called, right? Because there is no success. So this code is not executed, right? This is what you get from magnetic design. You kind of get this composability. Okay, so let's create it again. So let's create a bunch of spaces, description, and a bunch of spaces. Okay, press enter. Let's do the valid format. Okay, well, here's the red letter date in the history of science for my Back to the Future fans. 1955, November 5th. November 5th, 55. All right. The timestamp doesn't really matter. Let's do this. All right, so it says successfully created the new to-do. Unfortunately, we can't display it, right? So if we do SA to show all to-dos, it's going to say to-do. All right, maybe we should implement that first. Actually, it doesn't really matter, because if we implement that first, I'm going to have to create the entire to do again to show it to you. So let's just keep going. Should we keep going? No, let's not keep going. That's nonsense. Let's do show all. Let's do this one. Okay. So in order to do show all, let me quit. Let me go back to compiling. Okay. I want to have at least show all. Okay. Okay. So show all is going to call the application boundary read all. Read all. Okay, like this, read all, and it's going to save the answer in the variable called 0 or many, right? And it's going to call display 0 or many, like this, with 0 or many. And display 0 or many is going to be a tiny function called over here, defined over here. Display 0 or many. It takes a bunch of to-dos. Set of to-do dot existing, like this, produces a unit, right? And it's going to say, okay, so if to-dos is empty, right? So if there are no to-dos, like in the beginning, this is what it's going to do in the beginning. It's going to say display no to-dos found message, right? Like this, which is going to be defined over here. Private def display no to-dos found message, private, like this. Okay, it's going to be unit, and it's just going to say string interpolation. Okay, empty line, console.yellow, no to-dos found, console.reset, like this. Okay, so if there are no to-dos, we're going to see this. Okay, otherwise we're going to print out string interpolation. We're going to have an empty line. I'm going to say found, and now we're going to render the size somehow. And also, if it's one, we want to see to do, and if it's multiple, we want to see to do's, right? So the user experience completely matters. And then we're going to have an empty line like this. Why do I have a colon there? Oh yeah, I have a colon there because we're going to display the to-dos. Okay, so first rendered size, it's just a string, right? It's going to be console.green because I want to see the size in green, right? And then we're going to have the UX matters. UX matters is going to say, okay, so if to-dos dot size equals 1, then it's going to be to do, otherwise it's going to be to do's, and that's it. Okay, so now we have the fancy found blah blah blah. In fact, let's actually do this for now. Well, it should, okay, UX matters not found. I don't know what's happening today. All right, UX matters. Okay, so if we run and if we say show all, it's going to say no to do's found, which is cool. Okay, so let's compile again. Okay, so now let's actually display the to-dos. So we're going to say found blah 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 to-dos. We're going to have a column, and then we're going to convert to-dos to a sequence, just so that we can sort them by deadline. And sort by is a curried function, so it has 2 parameter lists, and over here it needs an ordering. We're going to have dedicated videos for that at some point, right? So we're going to use the oldest first, and oldest first is going to be defined over here. It's going to be defined by us. It's just going to be an object called oldest first, and it's going to extend ordering of local date time, right? And all it needs is a function called compare local date time and it's just going to use the compare to function that is defined on the local date time, x compared to y. Okay, let's see. Okay, so now this is a sequence which is sorted. In fact, let me do this. To sequence, I actually prefer to do this. There's also another way to convert things to sequences. Okay, like this, sort by. Now we're going to map this sequence to a function called rendered with pattern, right? We don't have this function yet, but then once it comes back, we're just going to print it out. Okay, so rendered with pattern is going to be defined over here. Private def rendered with pattern like this, and it's going to get the to do, one to do, right? The existing to do, existing, right? It's going to return a string equals. It's just going to return this interpolated string, right? So it's going to say rendered ID rendered description is due on rendered deadline, right? So now all we need to do is we need to declare them. So rendered ID, which is just a string. We could also use vals. It doesn't really matter. We can also use daps. It doesn't matter. So we're gonna have console dot green plus to do dot ID plus console dot reset. We're gonna have a val. Let's actually use daps, because with daps we have a little bit better syntax highlighting. It doesn't matter because we're gonna use them only once over here. Rendered description, right? Produce a string equals description is going to be in magenta. Everything is going to be very colorful. Okay, we're going to have to do dot description plus console reset, and over here we're going to have rendered deadline, which is just a string. The deadline is going to be console dot yellow plus to do dot deadline format with the pattern. So this is exactly why we injected the pattern from the main method, right? So if we go over here, it's going to be displayed in this pattern, right? Because this pattern goes into the entire class user interface, right? The entire code in the entire class, right? So it comes in over here and it's available in this entire scope. Even though we use it only once, I believe. Yeah, we only use it once over here. Right. So let's remove this empty line and let's see all of my typos. Knossel cream. Come on. Console.green. All right, so now everything works. Let's actually see. Let's run, and we're gonna create a new to do, blah blah blah, some sort of description, right? And the date is going to be 1955, November 5th. The timestamp doesn't really matter. Okay, so now it says created, and now if we say display all, which is show all, DA is delete all, not display all. Okay, SA shows all to dos. We should see this to do. Okay, so the ID is 0, the assigned ID from the persistence layer. This is a description. Notice that all the spaces are gone, and it's due on, and it's even though we entered it like this, right, in this form, it's rendered like that. Okay, which is really, really cool. Okay, so before we continue, what I want to do is, I don't want to create this to do every time if you want to play around with display methods. So what I'm going to do is, I'm going to go to the main method, and I'm going to sort of cheat a little bit. So I'm going to go to the to do app over here, right? And before I run the main loop, I'm just going to inject a few to-dos into the database. I'm not gonna go straight to the database. I'm gonna go through the application boundary to make sure that all the rules are maintained, right? So I'm just gonna call create one, and I'm gonna have to-do.data, and I'm gonna have a description equals first one. Doesn't matter what we're using here, all right? Deadline is local date time off. There are thousands of ways to create a date in Java or Scala. It's going to be year, month, day, and now we're going to have the timestamp, which is going to be the hours, 12:34. Okay, midnight, afternoon 34, and I'm just going to create two of them like this one. So there's going to be first one, there's going to be a second one, and I want to have the second one. I want to have the second one older so that you see the ordering. So what I'm going to do here is I'm going to do 2020 or something. I don't know. Let's say June 15. Let's do 4 o'clock in the morning. 4 o'clock in the morning. All right. Local date time is not there. All right. So we're going to import it. Import Java time dot local blah There we go. All right, so now if we run the application and I'm just going to say show all to-dos, it's going to show me these two to-dos. And notice that how it ordered them. Even though the first one you see like behind, you know, my console is transparent, the first one that was inserted was actually, you know, newer, but it sorted them the other way around because of how we implemented it, right? So over here, remember we said, where is it? Here, we sorted them by deadline, oldest first. In fact, let me try something over here. Can we do compared to this? Is this going to work? Because this might be a SAM type. It is a SAM type. That's really cool. Right, so this lambda is going to be converted automatically into an ordering, right? Because actually, let me show it to you like this. I mean, we already talked about this, right? So we can have a private def over here. I'm going to say this is an ordering of local date, and we can implement it like this, right? So instead of, I still have to call it object first, oldest first, oldest first. It can be a private def, or it can be a private lazy val like this, right? So this should compile local date time, sorry. There we go, right? So this compiles. So basically the compiler turns this into that. So maybe let's keep it like this. Let's keep it like this. But I'm gonna keep using the oldest first over here. Like that. There we go. Beautiful. All right, so let's go through this displaying thing again. So if we call show all, right, it's gonna read them all from the database, right, and it's gonna call this function. This function is gonna check if none are coming back, and if none are coming back, so if it's an empty set, then it's gonna display this. Otherwise, it's going to render size in green, right, which is why we see the size in green. Can I scroll up? Yeah, I can scroll up. Do we have it? Oh, we don't. All right, let me see. Run. Display all. This is why we see the size in green over here, right? Because it's two of them, we see to-dos, right, and not to-do, right? So we take all of the to-dos, that's a set, we convert it to a sequence, we sort them by deadline, oldest first, we map each individual one to a random with pattern. So what comes back over here is a sequence of strings, right? They're already rendered, so we just go through the sequence and print it out. And rendered with pattern just styles the ID, the description, and the deadline. In particular, it formats the date, right? And then it returns this interpolated string. All right, let's finish the entire application. Okay, so okay, this is the first one that is missing. In fact, there's only delete all, and okay, there are more. Okay, but it should be really fast. Okay, so delete. So delete is gonna say with ID prompt, right, with read1. So read1 is going to be a curious function, right? So we don't even have with ID prompt yet, but you already know how it's going to look like. We're going to have with read1, which is, you know, we're going to give it the ID. It's going to try to find it in the database, right? And then if it comes back, it's going to be over here, right? To do, right? So now we're going to go to the application boundary. We're going to call delete1, right? And over here, we're going to say print line console.green plus successfully deleted the to do plus console.reset. Okay, so let's have the private def with ID prompt, right? It's going to take the onValid ID function, or basically we can call it onSuccess, right? Let's actually call it onSuccess. So on success, it's going to be still a string, okay? Unit equals like this, okay? So with ID prompt is going to get the user input, standard, and read line. Please enter the ID, as always trimmed, okay? Now it's going to create the ID from string. This is the function that we will primarily need in the cake pattern so that you see the benefits. Over here, it's basically, you know, we're just gonna pretend like an ID that the user puts in might be invalid. Okay, we're gonna do like if it's empty or something, right? So if whatever comes back is the actual ID, then we're gonna call on success with the ID, same as before, right? Whoa. All right, so there we go, case none. So if the ID is invalid, then we're gonna print out long string again was an error message. So we're gonna say console dot yellow, very similar to what we did at the top, plus user input plus console dot red is not a valid ID, console dot reset, like this. Okay, so now we're just going to create the create ID from string function. So it's going to be here, create ID from string, right? It takes the user input, which is a string, right? And it's going to be over here. And all we're going to say over here is going to be if user input is empty, or if user input contains space, right? Then we're going to return none. Otherwise, we're going to return some with the user input, like this. Okay, so if it compiles, I just assume that it compiles, then with ID prompt is going to work. Now we also need the with read one. This is going to be a funny one. So everything is going to be underneath. Let me scroll up a little bit. Def with read one. It's going to take the ID, and as I said, it's going to be a current function, right? So it's going to be again on success. Success means that it's found, right? So it's going to have the existing to do, right? And everything returns unit. Okay, so it's going to say application boundary, and it's actually going to try to read it out, read one by ID. It's going to pass in the ID, and if whatever comes back is a sum, then we're going to call on success with it to do. Otherwise, we're going to display the same message as we displayed on the display all. Remember, we were saying display no to do's found message, right? So if we go up there, if I double click it, now where is it? There it is. It's going to say, it's just going to say no to do's found. Okay, so let's come back with read one. In fact, I believe it's done now. Okay, so we're saying with ID prompt, it prompts for the ID, and on success, you know, if everything is fine, it gives us the ID. Then the ID comes over here. We call it with read one. It comes over here. We actually try to find it in the database, right? If it actually comes back, only then we call on success, which is this one. So if we actually find it on success, you know, if we actually find it, then we're going to delete it, and then we're going to see that we deleted it. Okay, let's see if it compiles. There are probably typos again. Okay, oh, there are no typos. That's cool. Okay, so now let's run it. Okay, so if we show all to-dos, right? So now we're gonna say delete to-do, which is D, right? It's gonna prompt us for the ID. If we enter something wrong, you know, with spaces, it's gonna say, you know, the ID is not valid. Okay, so let's show all again. Okay, delete. Let's enter the ID. So which one do we want to delete? Do we want to delete the first one or the second? Let's delete this one. This one. So the ID is going to be 0, right? It doesn't contain any spaces and it's not empty, so it's going to be valid. Therefore, it's going to find it, and if it finds it, it's going to delete it, right? So let's try the same thing. So if we show all, see it's now gone. Okay. So let's also now enter a valid ID, but the one that doesn't exist. For example, 25, it doesn't exist. So now it's going to say no to do's found. So it actually didn't delete anything. Like show all again. All right, there we go. Okay, let's quit. Switch back to compiling and implement the next one. Okay, so everything at the top is already implemented. All right, this one, search by partial description. This is actually going to be a very small one because we already have all the things that we need for it. So we're going to say with description prompt, right? This is going to be the description, right? And we're going to say val 0 or many equals application boundary. In fact, let me put it to the next line so that it just fits better. Application boundary dot read many by partial description. D should be capital. Description, like this, and we'll pass in the description that is coming from from the user input, okay, like this. And now we're just going to display 0 or many, 0 or many, and that's it. This is what you also get from this monadity design. Okay, really? Did I mess it up? Oh, it's not a deadline prompt, it's a description prompt. Description prompt. There we go. You got a lot of type safety. All right, so let's run. And okay, so let's say, so this is the description, second one and the first one. Let's search for a partial description, which is this one over here, which is SD. Okay, let's search for description. And if we type something in that doesn't exist, I don't know, like a bunch of zeros, then it's going to say no to-dos found. But if we search for description like this, and we can have only a part of the description. So let's say, for example, FIR, right? Then it's going to find this one because FIR, even though F is capital, is contained over here, right? So it found one to do, and not to-dos, by the way, right? So let me actually show all. Do they have something called? Yeah, they have one. Okay, so let's search by description. Let's search one. Right, so now I actually found both of these to-dos. All right, so this is the find by description. The remaining methods are going to be, you know, really simple because we already have most of the things. Okay, search by ID, very similar. Instead of asking for the description, it's going to ask for the ID with ID prompt, and if everything is valid, then it's going to say 0 or 1 in this case. It's going to be I could basically almost copy paste it from the top. So now we're going to say read 1 by ID. ID comes in over here, right? Over here, we're going to convert it into sat, right? So 0 or 1 is an option. So we're just going to convert it into a sat just so that we can display 0 or many again. 0 many, 0 or many. This one. Let's see if it compiles, and it does. And let's run. Let's search by ID, which is SID. Okay, search by ID. Let's do 1. It finds this one. Let's search by ID 0. It finds this one. Let's search by something else like 1, 2, 3, 4. It's going to say nothing found. And let's search by an invalid ID, which is should this be an invalid ID? Oh, it's gonna, yeah, it doesn't understand this is not a valid ID because it doesn't know that it has to be an integer, right? So because the way we implemented the create ID from string is that it only thinks that the ID is invalid if we have spaces in it. So for example, 2 space 5. Now it's gonna say 2 space 5 is not a valid ID. All right, let's keep going. We are almost done, right? We have the update description and we have update deadline. Okay, so they're going to look very similar. So first of all, we're gonna ask which one do you want to update. So we're gonna find it by the ID, right? And then we're gonna read it out. Notice that we already have all of these functions, which is awesome, right? And then we're gonna ask for the description, right? Because you wanna update the description. Okay, description. Right now we're gonna have an updated to do equals to do dot with updated description, right? We're gonna save it, application boundary dot update 1 update did to do like this, and we're just gonna say that everything went well. Console dot green, whoops, green plus successfully updated the description plus console dot reset. All right, and that's it. If it compiles with updated, there we go. All right, cool. Now before showing you two, let me actually implement the last one, which is going to be very, very similar. In fact, I'm going to copy that. I'm going to paste it over here, right? So it's also going to ask for the ID, right, so that it can find it. But then instead of the description prompt, it's going to use a deadline prompt. Hold on, I can just do this, press A, press tab with deadline prompt. Everything that says description, no, everything that says description, right, is going to be deadline, right? And that's it. Oh, actually, I wanted to call this updated to do. Updated to do. All right. Okay, it's cool, it's fine. Okay, our entire application is actually complete, right? So we can show all. So for example, let's take this one and update the description. So let's see. Okay, update description is UD. Okay, so we want to find the one with a 0. Okay, and the new description is going to be new description. And again, spaces are all good, right? Oh, come on, I can go back like this. All right, I'm just gonna have a bunch of spaces in the end. Okay, so now it's gonna say successfully updated description. So if I show all, it's gonna say new description. And now let's update the deadline of the first one. Okay, so let's update the deadline, and the ID is going to be 1. The format, it has to be as always. So we're gonna say, okay, so it's 1955. So let's say, I don't know, 3000. Month is going to be, what should we take? Let's take October 10, and the day is 17. I don't know. Let's take 5/35, something like this. Okay, successfully updated. Show all, and we see it over here, October 15. Ooh, Friday, 17:35. Okay, so now our entire application is complete, and as I already mentioned, let me actually double check if it's complete. I'm not sure if, are there any question marks? Nope, 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 nope. It's all good, it's all good. All right, so this entire application is now completed, and this is the part which injects all dependencies, which this is the part that will, in the future video, it will build the entire cake out of this, right? So it's gonna assemble the cake over here. So we're gonna use a bunch of traits, and then these things will just be in scope. But we're gonna see that you know, once we reach that. But this is gonna be definitely in the second part, or you know. I have been recording for 2 hours now, so I'm gonna split these videos into a bunch of small ones. So the next video is gonna talk about the cake pattern. As of right now, like this video if you did, subscribe if you want to improve the developer inside you, and most importantly, take care.